This is problem 2.46. Here we have a second order ordinary differential equation with a nonlinear input force. As we begin to solve this, we will be using the trial solution method, which, as you can see here, x d e to the s t. And as I take its derivative, we get a few different terms. These are initial conditions that we'll use a little later to solve for our coefficients. But as we input these into the equation, we can cancel out like terms and generate a new equation, s squared plus 6s plus 34, which we can then use the quadratic formula to find our roots. After some math here, we get negative 3 plus or minus 5j. And as we put that back into our homogeneous equation, we get this solution. And we'll use this later once we find our particular solution to find these coefficients of b1 and b2. So as we begin to find the solution for the particular solution, we'll start with our equation here from our nonlinear term, and we'll need to take a few of its derivatives to satisfy our original equation. Keep in mind exactly what the derivatives are of sine and cosine. You can generate these expressions, which then substituted back into the equation is a little lengthy, but you get this first equation, simplifying, get the second equation, and after further simplification, you can get your a1 and a0. Here a1 is negative 1 1/30th, and a0 is negative 9/65. Now that'll give our coefficients of our particular solution, but as we use our initial conditions and combined our homogeneous and particular solution, we get a new expression here where we still need to solve for b1 and b2. After equaling this equation to our initial condition of 0, it further simplifies to b1 to be 9/65, taking the derivative of our time varying equation. We get this expression, which then simplifies to negative 3b1 plus 5b2 minus 6/130, which then after a little bit of algebra, you can find b2 is 6/65. And then just simply substituting these back into the equation to get our full expression of our time, we get this lengthy time equation. Thank you.